Awesome.
And I thought it was a quadratic, but it's not. It's like,
All right, well, binomial probability distribution is what we're going to talk about today. All right. Binomial distribution, two distinct outcomes, success, what's considered success and failure. An acceptable product or defective product. Good light bulb, bad light bulb. That's what makes, one of the things that makes something a binomial probability distribution is that you have those two outcomes, success and failure. So that's one of the things we've got to look at here. All right. So here's those three pillars or four pillars of binomial probability distributions. Okay. These requirements. First one, so there's a fixed number of trials. So five, we're picking 5 people, something like that. There's a fixed number of trials. The trials must be independent. Okay, so probability of the first trial cannot affect the probability of the second trial, third trial, whatever. Fixed number of trials, and those trials are independent events. So if it's deck of cards, is that with replacement or without replacement? With replacement. Okay, so that's the kind of the kicker here with binomial probability distributions. Fixed number of trials, independent events. When can an event be considered independent? If what are the stipulations when normally that event is a dependent event? When can we calculate it as if it were independent? Sample size. Sample size less than how much? 5% of the overall population. And the number of possible ones for that. Okay, so 5% rule could make something be treated as independent. It's normally not. So we've got to be careful of that. Each trial must have all outcomes classified in those two categories, success and failure. Whatever that is, that's going to change per the situation. But there's only 2 outcomes. There's a success and there's a failure. That's the third stipulation. Number 4, probability of success remains the same in all the trials. That's very closely related to independent events. Probability is the same. Fixed number of trials, independent, success and failure, probability is the same for every trial. Those are the 4 things that make something a binomial probability distribution. It's going to become more important as we get more distributions as we go forward from here. So, okay. All right. Success and failure, probability of success, P parentheses S, lowercase p is what we use a lot of times. Q is the probability of failure. So if you see the letter Q, you're talking about failure. That's 1 minus the probability of success. P, lowercase p, probability of success, lowercase q, probability of failure. N, number of trials. X is the number of successes in N trials. So 3 out of 5, 3 is the X, N is the 5. Okay. Any whole number between 0 and N inclusive, then you can have 5 out of 5. P again, probability of success in one of the trials. That probability of success should be the same for every trial if it's a binomial probability distribution. Good work. There we go. Q. And it's changing over here, but not changing up there. Awesome. I believe you're correct. Let's see. Just understand.
Pretty good though. I don't like that. I didn't like that. Really? I liked it, but I didn't like it as much. I thought it was almost. But I like Michael Keaton back in the movie. I hate Batman, but I love the first Batman. I think Batman, the original Batman, is better than Dark Knight. I agree. I like it as a player that movie. You know what I like? The Winter War. With Billy Blanco show. Like having history. Yeah, you just like, like, cause like, when she's giving me everything, I just live on. Yeah, it's like, I really like on skis, just running through, like grabbing logs, shoving the logs, shoving the logs through the tracks of the tanks.
All right, guys, here we go. We're back in business.
Yeah.
All right, so Q, probability of failure. P of X denotes the probability of getting exactly X number of successes in N trials. Okay, so that's exactly that number. Now we're still going to have to deal with the ORs, 3 or more, 4 or more. Have 3, out of 5 trials, 3 or more successes. Less, 3 or fewer successes. We still got to deal with that sort of thing. That's what's going on here. Be sure that X and P both refer to the same category as in success. Sometimes they will kind of switch it up on you in the word problem. They'll give you probability of failure, and you've got to find probability of success. So make sure that X and P are both referring to success. And here's that rule about 5%. If the number of trials you have is less than 5% of the number of the population, then you can treat it as independent, even though it normally wouldn't be independent. Okay, so that 5% rule is carrying out throughout our text here. Okay, here's an example of how we can do this. I'm going to show you some ways to do this. There's a formula that we can use. I'm going to show you actually how to do it with the calculator as well. So an adult is randomly selected. There is an 85% probability that the person knows what Twitter is. Not sure how they got that number. They did some sort of survey and were able to determine this probability. You're given that probability. So suppose we want to find the probability that exactly 3 of 5 randomly selected adults know of Twitter. Does this result in a binomial distribution? So what are our rules for binomial distribution? Got to have a set number of trials. How many trials are in this example? 5. Okay. We have to have a number of successes. 3 successes. We have to have a probability of success. Probability 0.85. There's a probability of failure. It's 0.15, right? So that's the same for each person, each adult that I asked, according to our data. Okay, and then independent events. What I ask, they are, because if I ask this person, it doesn't affect what this person says. I guess unless they're standing there when you explain to them what Twitter is, but I guess that would be. But if it's all practical purposes, they're independent. Okay? So this is a binomial distribution because it meets all 4 of those requirements. Got to meet all 4 of those. Okay. Methods for finding probabilities. So we're going to talk about finding those probabilities for X number of successes Here's the formula. Okay. N factorial over n minus x factorial, x factorial. Should look familiar. I'm going to show you that. P to the x, what's P represent? Probability of success to the x power. So if we're looking, our situation here, 3 out of 5, x is going to, we're going to take 0.85 raised to the third power. Q is going to be 0.15 raised to the second power. Because 5 minus 3 is 2. Okay. That n factorial, n minus x factorial, that formula, what's that the formula for?
I know.
Yeah, it wasn't long ago. Combination. I can do that. All those things. All right. Technology, we don't use Minitab, we use TI-83 or 84 plus is what we're going to use. Okay. There are tables in the back that you can use that Coach Mack and I were talking about that in the end. That when we went through stats, the tables is what it is. Not everybody, you didn't have such great access to graphic calculator. So, let me get to the problem. All right, so here's our problem. We want to find the probability of exactly 3 out of 5 adults that we asked. Okay, so this is what we're trying to do. We have in 5 trials, 3 successes. Probability of success is 0.85. Probability of failure is 0.15. Binomial probability distribution. Meets all those requirements. We want probability of exactly 3. Okay. This formula does that. Okay. What this finds is how many common ways we can get 3 out of 5. First one, second one, third one. First one, third one, fourth one. First one, second one, fifth one. That sort of idea. Okay. And then it works out there. It's 0.138. That's the probability of getting exactly 3. Okay. That's that formula. I'm going to show you how we can get that on with the TI-84. Oops. All right, with the graphic calculator, you want to hit second and then the variables button, which is distributions. We're looking for a binomial distribution. So we scroll down through there till we find binomial PDF, probability distribution. CDF is a cumulative distribution, so it's adding up the probabilities as you go. That's what the C stands for. PDF is what we want, because we want to find exactly that. So I'm going to hit enter there. If you've got the newest operating system and you're using one of our color ones or one of the ones we rent out, you should see this. Anybody not seeing that? Johnny, I figured you would be. Number of trials is how many for our problem? 5 trials. Johnny, type of 5. Hit a comma. Probability of success, 0.85. How many successes are we looking for? 3. So, comma, 0.85, comma, 3. I think is the right way, Johnny. It's been a while since I've done it. Yeah, that's right. Yours look like that?
Yeah.
All right. Rounding 3 significant digits there, 0.138. That's for an exact number of successes. If you needed probability of 3 or fewer, what would you need to do? Yeah, we would need to find probability. This is probability for 3. We need to do probability for 2, probability for 1, probability for 0. and add all those others. If we're going for 3 or fewer. If we're going for 3 or more, we would need probability 3, probability 4, probability 5, and add those up. That's that same idea as we had last chapter. We did that where we're getting that cumulative probability out of that. So here you want to start with the, here we're looking for an exact number. Okay, so how do we get there again? Second, variables for distributions. We're looking for binomial PDF. Yeah, that's the way to do it. All right. Many trials you got, the probability of success. Make sure you find probability of success. And then X value, that's your how many successes you want.
I like the section.
Yeah, it's not bad.
Section 4. Yeah.
Is it? All right. So here we go.
Really don't pick that up in the recording.
All right. You're close enough. It did.
Like it might be just a mumble.
It may be. All right. Section 4. All right. So still dealing with binomial probability distributions. Okay. So important characteristics of those, including the center, variation, and the distribution of that of a particular binomial probability distribution. So we're looking at mean, standard deviation, variance, those things. Okay. So this is interpreting and understanding those values. We're interpreting what they mean, what we're going with. So here are our formulas for this. This is something you will need to know. Okay. When the calculator gets you those probabilities, this is going to give you the mean, U, number of trials, N, times the probability of success. So for our example that we just did, what are the numbers we're multiplying together there? Yeah, 5 trials and 0.85 for probability of success. That gets you the mean. The variance is found by multiplying the number of trials times probability of success times what's Q stand for? Probability of failure. Okay? So the variance is multiply all 3 of those together. Variance is always the square of standard deviation. So to find the standard deviation, you just take the square root of the variance. Mean can also be called the what? Mean. Mu, the letter, the Greek letter we're talking about here. What was it called?
Value.
Expected value. Another name for mean.
I got those questions wrong.
But you learned something about them, though.
I already knew that. It's just I got to fix
I just missed it on purpose. Just see if you were paying attention.
Always, every single test,
Everything's a test, yeah. All right, so mean, expected value, trials times probability of success. Variance, trials times probability of success times probability of failure. Take the square root of that to get your standard deviation. Okay, range rule of thumb, is that any different? The same range rule of thumb we've been dealing with for 3 chapters now. It's not changing. The independent event rule, 5%, hasn't changed. All of that's still the same. It's not anything new there. Okay, so usual values, plus or minus 2 standard deviations. From what? The mean of the expected value. Okay. Here's an example. We got McDonald's has a 95% recognition rate. You ever played that? There's an app. It's a game for recognizing logos. You ever played that one?
Yeah.
It's pretty fun. Frustrating when you don't know.
Wonder you don't know.
Yeah, you never seen it before. But that's that recognition rate. McDonald's has 95% recognition rate. And special focus group consists of 12 randomly selected adults So the mean and the standard deviation for such a group, or the expected value, is that 11.4 of those people, or 11 people, would know what McDonald's is. That's what we're finding here. 12 trials, that's the number of randomly selected adults, and 0.95 probability of recognizing McDonald's, and that gets you your mean or expected value. Our standard deviation, square root of the variance, so NPQ, so 0.95 for the P, probability of success, 0.05 for probability of failure, still 12 people. I'll file those two together, and our standard deviation is 0.8. And rounded to one decimal place. Why did we round to one decimal place? It's one more than what we had, what they gave us.
That's the other one.
That's absolutely correct. Okay, from that we can find what would be a unusual value. So less than 9 people or less would be unusual. If what this tells us is, in a group of 12 people, it's not unusual for all 12 of them to know what they got. Right? Do what now? Almost, yeah. Almost.
We're working on that.
Yeah. So, section 4 brings in some of those things we've been doing already. Section 3 is all about the binomial probability distribution, those new things. Section 4 brings in the things we've already been doing. Okay, so that's what we're working on for